All right. So what we're going to talk about today is actually application of Pythagoras' theorem. What I would like to do today is I need you to recall what Pythagoras' theorem is. And you should know that it is a useful tool in determining the unknown lengths in right-angled triangles. And it has actually quite a widespread application. You also need to recognize that right-angled triangle calculation may generate results that can be integers, fractions, or irrational number. Of course, you know what integers are. You know what fractions are, correct? Yeah? Yeah? But do you know what irrational numbers are?
Yeah.
What?
Yeah. It's like
They are the
numbers without a pattern.
yeah.
Sorry?
Numbers without a pattern.
Numbers without a pattern.
Numbers that can't be represented in fractional form.
Thank you. What
Yes,
else?
That's
That.
yeah.
Yeah. Okay. Well, it is correct. It doesn't have a pattern as well, and it's also a number that cannot be represented by a fraction. So if you think about irrational number, something like 1 over 3 is not, because 1 over 3, although is never ending, it can be represented by a fraction. Something like pi
So
is irrational because it goes on and on. So on and so forth. Something like square root of 2, it goes on and on. So what we need to know is when we look at Pythagoras' theorem, alright, when we work out the sides, you may have something in fraction, decimal, integers, or irrational numbers. Sometimes you need to represent the numbers in terms of something like square root of 2, square root of 3. The main reason of using that is it is exact value. Alright? It's not approximate value. Alright? It's a not approximate value. And you need to be able to apply Pythagoras' theorem in real life. All I can say now is, please read my comment on your report. Alright? Now, for a right angle triangle, hypotenuse is always the longer side, which is directly opposite the right angle. Alright? That is what you need to recall. Now, if I've got A, B, and C, of course C is the hypotenuse, opposite the right angle, and you know Pythagoras states that for right angle triangle only, A squared equals to plus B squared equals to C squared. So in order to determine C, if we know A and B, C is actually equals to square root of A squared plus B squared. Correct? So therefore, you could have an irrational number, which is something like square root of 2, square root of 13. Square root of 15, I'm pretty sure is irrational as well. So something like this, sometimes you actually do need to represent your number in such format. And to work out A, if you know C and B, you know A will then be equals to square root of C squared minus B squared, correct? Or to work out B, if you know C and A, B is actually square root of C squared minus A squared. Alright? So this Pythagoras' theorem only applies to right angle triangle only. No other type of triangle. Any question before I move on? Take you back to some examples. Alright, before I take you to some example, let's have a look at the summary. For any right angle triangle, the square of the hypotenuse equals the sum of the squares of the lengths of the other two sides, which is A squared plus B squared equals to C squared. Now, this is important. Any triangle with side lengths of any triangle with side lengths of A, B, and C, which satisfies C squared equals to A squared plus B squared, is actually a right angle triangle. Alright? Now, can you therefore find the value of x? You are allowed to use your calculator in this case. Use your calculator. If you haven't got a calculator, grab a calculator, please.
Square root.
Calculators here, if you haven't got one. Oh, yeah. If you haven't got one, grab one, please. No.
Yeah, and you have to square root. Oh. Approximately 30.
Wait, Mr. Lowe,
Yep.
it has 8 plus 8. Isn't it just x
It's
equals
this
x
word
squared?
how to square root it. You have to start it again.
Oh, I think
It shouldn't be x squared, it should be x. Alright, I don't have any units, that's why I put down 13.27 units. Alright, you've got to be careful in terms of rounding. I have given you in this format which is in decimal. Therefore, you give your answer in decimal. Watch out for the decimal places. You've got 2 decimal places here and 1 decimal place here. Alright? So you can give your answer in at most 2 decimal places. Not more than 2. Alright? So you must remember how you round up. Alright? Next one. What I've done is I've just swapped it around. 12.25. This time the hypotenuse is 12.25. Can you find x? Slightly different this time.
Oh, you just put square root.
Alright. Now, what I want all of you to notice with those two. It makes sense because that the hypotenuse has to be longest. Correct? So therefore, when you have this value, it has to be positive inside and you can get a square root. If not, you won't be able to get a square root. So think about it, the longer side is always the hypotenuse. And whatever you get, just give it to 2 decimal places because there are 2 decimal places and 1 decimal place. Alright? 2 decimal places. Now, another example. Oh no, not example. Can you remember what Pythagorean triples are?
Do we have to know them?
Sorry? Yeah?
I think that was like 3, 5, and another number.
Yep. So, thank you.
Yeah.
So what Eleanor said is, it's something like you've got 3 numbers, alright? 3 integers. A squared, B squared equals to C squared. Alright? There are lots of Pythagorean triples and sometimes it actually helps to remember some of that. For example, I know that one, I know that one, I know this one. The other one I know is this. I know 4 and straight away if I look at triangles given, I can actually just guess that it's a right angle triangle. It's actually useful skills to have. Certain things, I'm so used to it that as soon as I look at it, I know that that would happen. Alright, it's just a matter of practice. Once you get a bit more experience, you will know. Of course, you don't have to memorize or remember something which is that big. Okay. Now, Pythagoras' theorem in real life. It actually used quite a lot in architecture and building, how they actually design, for example, a roof. They can work that one out. They know that it's a right angle there, and therefore they can work out what the hypotenuse is, or work out what the height is. So if they know something like the value of the base of the roof, they know what the side they want, and they know there's a right angle there, they can actually just work it out quite easily. So it's useful in architecture building. It's useful in navigation. Think about navigation. We will talk about navigation a little bit more when we come to third term, when we talk about bearings, angle of elevation and angle of depression. Screen size, TV monitor and phone screen. Now, if you go and buy a TV, they will give you certain numbers about the size of the screen. In fact, the size of the screen is not the width or the length. It's actually the diagonal. You measure from one end to the other end. Right? It's never this or that. It's always any screen that they advertise is always from one end, one corner to the other, the diagonal. Or from there to there. It doesn't really matter. It's here to here or there to there. It's all right. It's the same. So you can see that it's worth. You can use Pythagoras Theorem and work out the screen size. All right. So now to some examples. A 10-meter ladder leans against a wall with its foot on the ground 5 meters away from the wall. Find how far up the wall the ladder actually reaches. So you know that the wall, all right, and the ground is 90 degrees, correct? And the ladder is leaning on it. In this sort of situation, what I would do is I will draw a sketch. All right? Of course, I got this example from the net because I got a diagram. You can see that if this is the ladder, you actually do have a right angle triangle. You know this is 10 meters, this is 5 meters. You don't know how far it can go up. So can you use Pythagoras theorem to work out what h is, please? Grab your calculator and start doing that. All right, now, here, I want to introduce you to the word surds. All right? I want to introduce you to the word surd. All right?
What's a surd?
Focus for a minute, please. Did you get the same answer as I do?
Yeah.
All right? Here, square root of 75. You know that square root of 75 is actually what I call an exact value. All this square root of 75 in decimal is approximate value. All right? You can't get an exact value of 75. You know square root of 25 is exact because it's 5. Correct? Now, therefore, what I want to show you is the word surds. Surds means you got something like this. You cannot get an exact value, and it is actually an irrational number. Now, at this stage, I'm not going to show you how to simplify a surd yet. All right? You can simplify a surd. For example, this is, I will quickly show you 75 is 25 times 5. Correct? Sorry, not times 5, times 3. My fault. Times 3. So therefore, you can actually get the square root of 25, which is 5. Alright, this is for you to learn next year. I'm not going to teach you how to do it yet. So in your book, if you are asked to simplify the surds, you don't have to do that. Any exercises? If you got a square root of 75, just leave that square root of 75. And that would be the exact value. Alright? You don't have to do that yet. Not for this year. Next year, year 10, you will learn how to simplify cert. Alright? So I want you to recognize from this, when you do a calculation based on Pythagoras Theorem, you could actually get a cert or exact value or decimal, which is approximate value. Alright? Everybody got that? Yep.
So the longest side of the hypotenuse is C. For like in the theorem. C
No. Sorry. Repeat again.
The what is C?
C is the longest, the hypotenuse.
Yeah.
That's
Yeah,
correct.
so-
That's a hypotenuse, C is C. Hypotenuse. Alright? Now, next question. Mary wants to get a computer monitor for her desk, which can hold a 56 centimeter monitor. She has found a monitor 40 centimeter wide and 25 centimeter high. Will the computer fit into Mary's cabinet? Not cabin, cabinet. So you know that the cabinet, it can fit 56 centimeter monitor. Alright, this is the cabinet. Now the monitor has got, it's actually measured 40 centimeter and 25 centimeter. Can you work out the size of that, please? What is the size of the monitor? X will be equals to Am I right in that case? So, we don't know what square root of 2225 is, so you need to work out which is 47.17 centimeter.
Oh, you got wrong. He's 17. Isn't it?
17 because it's 169. So since 47.17 is less than 56 centimeter, the monitor can fit into the cabinet. Alright? Focus please. Now, 47.17 is less than that. So the whole thing can actually fit in that, correct? Yeah? Do you agree?
Yes.
Very good. Alright, next example. These are all practical examples. Looking at 2D first. We'll do 3D next week. Now, Bob is meeting his friend Peter in a park. He has two ways he can go. He can follow the road and roads getting to the park, first heading south 3 km, then heading west 7 kilometers. The other way he can get there is by cutting through some open fields and walk directly to the park. What is the shorter distance? You know one of them, he will walk south 3. Alright, let's draw it up. This is some navigation problem. So I'm going to start off with here. Bob is here. Alright, starting point. Walking down south 3 km and then walking west. Oops, 7 km. Alright, supposed to be a straight line. Now this is right angle because west and south is right angle, correct? Yeah? So if you draw, this is north, west and south. Now you need to find if he starts from here and cross to the park. Alright? Through some open spaces. What is the distance? Sorry?
Do we have to know the distance, or do we just need to know which one's shorter?
No, you need to know the distance. Work out the distance. Alright.
Because we know the x is shorter,
Yeah.
obviously, but
Listen, you always know x is shorter, but in maths, you always have to quantify the value. So x is therefore square root of 3 squared plus 7 squared, which is square root of 9 plus 49. which is square root of 58, which is square root of 58.
7.662
62 kilometers. So you can see that it is shorter for Bob to actually walk through the open space. Alright? Now, question like this, it asks you for the shorter distance. You don't actually have to work out the difference. What Harrison said was right. You sometimes, when you need to compare, you always need to work out the difference between one distance and the other. Alright? The question is, what is the shorter distance? That's all. You don't need to compare. But if you need to compare, you've got to work out the difference. Alright? So these are the examples I have for you. You need to be able to recall Pythagoras' theorem, which I hope you have, and be able to apply Pythagoras' theorem to real life situation. And you've got about 25 minutes to do some work from the book. Thank you.